午後のセッションに入りたいと思います。まずは AI 時代の中立かつプログラマブルなお金というタイトルで、ライトニングラボの、Head of Product Growth マイケル・レビンさんから、プレゼンをやっていただきます。Please.
Thank you. Yeah, so I'm Michael Levine. I'm head of product growth at Lightning Labs. I'm super excited to talk to you all today about neutral programmable money for the age of AI. Before we dive in, I just want to talk about kind of why I think this is important. I think as we move from a world where Bitcoin is a store of value into thinking about it as a medium of exchange, it's really important that we identify sort of use cases and industries where Bitcoin and Lightning can play a critical role in payments infrastructure, right? And so I think, the age-old sort of example is paying for coffee. But when I really think about the way that these things are going to take off, the way that Lightning is going to take off as a payment system, it's in ways that we can't even imagine right now, right? It's machine payable web, it's different things like that. And so I think it's really important for us to look at growing industries, at new technologies, and think about how Bitcoin and Lightning can fit in, and how we can provide value to those developers and those entrepreneurs. So in terms of what I'm going to talk about, I'll talk first about kind of the promise of AI, the costs associated and the implications of those costs. Then I'll move into the role of payments across the AI stack, a payment system designed for AI from like a first principles level. I'll then talk about the L402 protocol, which is something we introduced at Lightning Labs a few years ago, get into AI Lightning Network adoption thus far, and then talk about how we think about supercharging that adoption. So first on the promise of AI, but before I dive in here, I'm curious how many of y'all actually use an AI product on, like, let's say a monthly basis, something like ChatGPT or an open source LLM, or okay, yeah, I mean that's a huge number, or a huge ratio. I think it's been pretty crazy over the past 2 years since ChatGPT initially came out. There's been a meteoric rise of AI products. The saturation rate of people who are using them is record highs. The adoption curve, especially for more technical people, developers, things like that. And the focus has been on the creation of these LLM platforms along with chatbots, right? But I think the next phase, which is great timing for me because there was recently the release of the OpenAI 01 product, is AI agents which will be able to accomplish tasks and operate in sort of a multi-step logical fashion, right? So you go from a world where you're just asking an LLM what's the best ramen restaurant in Tokyo, and it gives you 3 recommendations, to a world where you're saying, book me a trip in Tokyo with flights, hotel, restaurant reservations, and it goes through and it sort of executes against each of those different tasks and returns back to you. And once we get to that point, I think it'll be really interesting because you'll need a payment infrastructure, right? And that's what we're going to kind of talk about today. Before I go to the next one, I just have this little chart here that I pulled from a research report I was reading about kind of the GDP impact globally of AI over the next 10 years. Projected to do anywhere from 1 trillion to sort of like 5 trillion in GDP impact. I think it's just going to be a huge industry that blows up that everybody's using, and we want to think about how Bitcoin and Lightning can play a role here, right? So that's the promise of AI. I think you also have to think about the costs of AI. And so at the highest level, these models are generally made up of 3 things, right? The compute, the algorithms, and the data. And those things are all extraordinarily expensive, and they actually require upfront investment, right? And so the first 2, compute, this is a quote from Ben Bajran, who's a research analyst who's done a lot of good work over the past 20 years or so. The cost of an AI server is like 400% more than a general purpose server. And then on the training and algorithm side, you have the CEO of Anthropic predicting $10 billion to $100 billion in training costs as we move towards more advanced models in 2025 through 2027, right? And those are the 2 things that people think about when they think about the expense of AI. They're like, okay, I know GPUs are expensive, I know the energy input is expensive, I know it takes a lot of time and effort to train these models. But one thing that I think people don't appreciate or aren't thinking enough about is the data. As these models get more and more advanced, data is going to be kind of a differentiator for the accuracy of the models, for what they can accomplish. And so I think more companies are starting to think about this. You had Google, like I think 2 or 3 weeks ago, that struck a deal with Reddit to get access to their data. They're paying them $60 million a year. Reddit referenced this in their most recent earnings and talked about how they plan to monetize all the unique data that they have with these AI companies and these entrepreneurs. And this deal is like very fiat economic model based, right? It's like $60 million per year and we get access to your data. As we move forward, I think there will be new constructs and new ways to think about how do these models get access to data that they can train with or that agents can use to actually deliver value with based on a query that someone asks. So with those costs, there are kind of implications, right? So if you're thinking about a consumer AI company, the audience actually has to be kind of the entire world with access to internet. You have all these upfront costs. In order to monetize that, you need a really, really, really big audience. Now there will be enterprise AI companies, obviously. They'll charge a high price to companies and they'll make it back that way. But you need something that is accessible for everyone. Additionally, I think one really unique thing here is over the past 25 years of the internet era, the evolution that we've seen is that the marginal cost of serving content or of serving answers is zero, right? You think about it, you go to Google, you type in a question, it delivers links, maybe a summarized answer, maybe some ads. That doesn't really cost them anything to deliver that one answer. That shifts with the sort of introduction of these AI models. There actually is a cost associated with the query that you're asking, and once you ask it, that's a sunk cost for them. They have to do the compute and actually get that answer. So the business model kind of shifts from where it's been, which is ads-based, and maybe we see some ads-based products, who knows, but to a world where you have to serve everyone with an attached cost. So the question is kind of, how do you charge everyone on Earth on a per query basis, right? And I think the per query part of this is important because the other thing to recognize is that the cost of a query is totally dependent on the content of that query, right? If you're asking to just do like a grammatical check on a sentence, that's probably pretty low cost. If you're asking for a complete code refactor of this very long piece of code and then asking to do some analysis on it, that's significantly more from a cost perspective. And so that's something we'll talk about a little bit later on as well. So next I just want to talk a little bit about the role of payments across the AI stack. I talked about data before and how the deals that are being made between companies like Google and Reddit are constrained by traditional economic models, just like I will pay you this amount, I will get this data for a year. I think we're going to see models that are enabled by some of the stuff that I'm going to talk about in a little bit that allow for pay-per-use APIs and different things like that, where an agent can get access to data just by paying an API to get a particular type of data or a particular string or something along those lines, and that'll be really interesting to follow. The other thing, I mentioned this already, but kind of accessibility, given the costs, you really need to have a massive audience. And right now we're seeing a bunch of these companies just use credit cards and subscriptions. Over time, that's going to become more difficult. You can't reach emerging markets as well. And so you kind of need a global system for people to be able to access these things. And then finally, last but not least, I think the role that agents will play will be really, really fascinating when it comes to payments in the AI space. Because when you go through these multi-step logical processes, either agents are paying each other or paying an API for access to data, or they're paying for real-world resources. They're booking a hotel or something along those lines. They don't have an ID, they don't have a bank account, they don't have a credit card. They're internet native, and they shouldn't be paying each other via a wire transfer or ACH or something along those lines, right? So we'll see kind of the way that Lightning and Bitcoin can play a role in that as well. So with all that said, I want to think about, like, from a first principles perspective, designing a payment system for AI. And I think it needs to be globally accessible, like we talked about. It needs near instant payments. It can't be wire transfer based or anything like that. Final settlement is also really important. A lot of these companies are already dealing with issues whereby a user will sign up, will do a bunch of queries, and then will claim fraud on their credit card, and they'll be charged back. And like we talked about before, it's not marginal cost is zero. There is a cost to answering these queries, right? So if I go and do 200 queries and then say, fraud, chargeback, the company has already spent the money to answer those queries. They lose that money. It's a sunk cost for them. Internet native is obviously critically important. You need an authentication mechanism. You need to be able to say, this user gets access to these different types of queries, or this tier, or this expiry date, or something along those lines. And then it also needs to be easy to implement. I think, a lot of these companies, when you think about entrepreneurs in particular spaces, they're focused on their problems. They're focused on solving user problems in their particular space. They're not necessarily thinking about other things, right? And so they're all trying to design the best AI user flows, the best LLM user flows. They're not necessarily thinking about payment systems. And so when we get to that point, I think it will need to be easy for them to implement for whatever they choose. So then just kind of want to introduce the L402 protocol alongside Lightning Network. L402 is something that we introduced a few years ago at Lightning Labs, and it's basically an open protocol that implements internet native paywalls by building upon the HTTP 402 payment required status code in the Lightning Network. So first let me just talk a little bit about the HTTP 402 payment required status code. It was a status code that was actually introduced when they were originally speccing HTTP, right? And it was reserved for future use. And basically what it means is a client requests access to a resource and the server says, you have to pay for this, right? So it was kind of earmarked as this thing that could be used with an internet native micro payment system. That didn't exist at that time. Bitcoin and Lightning did not exist at that time. And so it's kind of sat for a very, very long time, but it's throughout the entire architecture of the internet. This exists already. And so what we've done with L402 is allow the ability to use that existing internet architecture, but use Lightning and Bitcoin as a way to sort of pay for resources, to do microtransactions. And so I'll talk a little bit about how this works. There's a sequence diagram up here. It's pretty simple, pretty straightforward, so if you're not technical, you should be able to follow along. But basically, the client requests access to an HTTP resource. Let's say, an article, a news article, right? So they request access. The server checks the client credentials, and when it realizes that those are invalid, they haven't paid yet, it generates a challenge, which includes a macaroon and a Lightning invoice. I'll talk about macaroons in more details in a second, but you can just think of them as like a bearer authentication token. They basically are like a identifier, like your username and what you have access to, right? So you generate the challenge, the server sends that back to the client, and they have a macaroon and an invoice. They pay that invoice. They get the pre-image for that payment, which acts as a proof of payment. They attach that to the macaroon, send it back to the server, and then the server says, okay, you completed this, you paid for this, let me serve the resource that you requested, which in this case is an article, right? And so that's how, very simply, you can do things like pay-per-use APIs, you can do things like paying for news articles, all sorts of different things, and you can kind of make these payment metered servers. So the key concepts here to understand are macaroons, again, bearer tokens that enable decentralized authentication. And the reason this is decentralized is because it separates the issuance and the verification, right? You can have a macaroon issued from one place and use it for authentication somewhere else. And so that means that things are fairly decentralized from an authentication perspective there. There's invoices, Lightning invoices. The server includes an invoice in its response. The client pays the invoice to gain access. Then there's pre-images, so every Lightning invoice has an associated pre-image that's revealed when the invoice is paid, can be used as like a proof of payment. I paid this, I attached this to my macaroon, now give me access. And then the last thing here is a reverse proxy that sits between the server and the client, right? And this, we have our own implementation of this called Aperture, but anybody can make a basic reverse proxy for this to work. And essentially, this serves as a bridge between the L402 enabled client and the server, which doesn't have to have any awareness of L402s because of this reverse proxy sitting in front of it. So it handles the protocol negotiation, pricing, authentication, API key creation for the backend. So when we're talking about what this enables, we go back to kind of the ideal design for an AI payment system. And this is a perfect fit for AI. It's globally accessible, near instant payments, final settlement, internet native. There's an authentication mechanism built in with those macaroons. It's easy to implement, It's also language agnostic, and one thing we've heard more and more from AI developers is about granular access control. So these macaroons allow for you to be like, okay, this user only has access to this model for this number of queries over this time period, right? And that's getting more and more important, again, because the cost of queries is widely different. And so being able to say, you only get access to this is really important for these developers. So this video, let's see if I can get this to work. Yeah, this shows just like a basic demo of something that was built by Cody Lowe, which basically uses L402 and the Lightning Network to just have a basic like chat UI that has access to GPT-4, I believe. And so you put in a query, and then you have to pay a Lightning invoice in order to get access to the response of that query, and it gives you a response. And then if you do another one, same thing. But you could, create a system whereby the macaroon has access to a certain number of queries or anything along those lines. So, point being, like, this is all out there. This is all stuff that's doable. This is all stuff that people are already working on, there we go. And we have companies who are using L402 and Lightning Network today to build products in this space. So FuseSats is one of those. They're focused on sort of AI developers, but they're building other stuff along the way. They have a storage as a service product where you pay per download of files. They also have a data as a service product. So you give them a SQL schema and data, and they'll deploy a payroll to GraphQL API for you. You have Sulu, which is kind of pay-as-you-go API monetization and access. You basically pay per API call. They have a bunch of companies that have put their APIs behind these L402 payment metered systems. And then they have a bunch of like indie developers who are starting to use this stuff more and more. And basically cost scales with usage. And then finally you have kind of the open agents, pleb AIs of the world. They give access to open source AI, all allowing chat interfaces, and you pay per query via Lightning. With all of that said, this exists, this is here, there's a bunch of AI companies. I talked about how much the space has grown over the past 2 years. And so a question that I always had in my mind was kind of, why is there slow adoption of this stuff? Like, it fits so well, why are we not seeing more and more people using it? And I think that there's two factors here. One, the AI hype cycle is at an all-time high, right? If you want funding and you have AI attached to your startup name, you can probably go and get funding. And so monetization is not really top of mind for these companies right now, right? It's like internet in the late 90s, early 2000s, where you had the Googles of the world. They were just focused on user growth, user acquisition, usage, and not thinking about monetization at all. And so one example, you have OpenAI. They have a run rate of $2 billion as of December 2023. Their revenue is about 160 million monthly earnings. They are training even more advanced models. They're going to need tens of billions of dollars, and they're probably going to be able to raise that amount. But that's just like kind of the top example. If you waterfall it down to other AI companies, you're going to get similar sort of things. And so these folks have no reason to think about novel ways to do monetization. They're just thinking about user growth. Eventually that will change, just like it did for the internet. The hype cycle will die down. Unfortunately, some companies will die. Other companies will have to figure out how to innovate and create new ways to generate revenue. And then the second point, which is difficult potentially to talk about at a Bitcoin conference, but Bitcoin payments are still really difficult to sell into industries that are not focused on Bitcoin, right? Like, I'm an AI entrepreneur. I'm focused on delivering value for my users. Someone comes and pitches me this thing. I'm super stoked about it. I think it's like a perfect way to monetize all the things we talked about: globally accessible, near instant payments, per query costs, all that different stuff. And then they say you have to accept Bitcoin as your revenue, right? And then you have to go into the whole pitch about the global macroeconomic system is broken, and this is inflation resistant. And these folks just like, they're not there. They don't care. They just want something that works. They want to generate revenue. And so developers building these tools are kind of looking for stable coins. Like the developers who are pitching AI companies within the Lightning Network are looking for stable coins to come on the Lightning so they can sell that as a payment mechanism to AI companies. It just makes the pitch so much easier. And so when we think about what's going to supercharge adoption in this space, I don't know how many of you here were here for Lalu's panel yesterday to talk about Taproot assets, which is a Taproot powered protocol for issuing assets on Bitcoin that can then be transferred over the Lightning Network. We had a recent launch here where we have the first multi-asset Lightning protocol on mainnet. And there are actually companies already who have bridged stablecoins over. They've bridged Tether over to Taproot assets, and they're using it to send stablecoins on the network. So this was like a launch that we did, I don't know, maybe a month or so ago, and we're already seeing a lot of activity here. I think there's another conference in Singapore this weekend, and there was a company that did, I think 50 to 100 stablecoin payments on Lightning. So we're really excited about the potential here for a variety of use cases, but in particular for this one, where we've heard time and time again from these entrepreneurs who are building these AI Lightning Network solutions that companies are way more intrigued if they can receive stablecoin payments. So we think that this has the potential to bring this adoption to the next level, to really ingrain ourselves in this very highly growing space. And we're super excited about where developers take this moving forward. If you want to learn more about L402, about all the stuff I talked about, you can go to l402.org. You can go to our Builder's Guide, which has a lot of technical documentation about putting this stuff together. We also have a YouTube, which has a few demos, including one where we run all of this stuff in Replit. So we run Aperture in Replit. We have like a node in Replit, and we kind of do the flows there. Yeah, we have a couple of blog posts on our website as well, where we talk about the launch of this stuff and what you can use it for. Yeah, well, I really appreciate the time. I enjoyed talking with y'all. This is a topic that I'm passionate about. I think it's going to be important as we move forward with Bitcoin as a medium of exchange. So thank you. Feel free to ask any questions.
Thanks, Michael. We do have a few minutes. Could take maybe 2 or 3. Saw the one at the back first.
So thanks for the presentation. I came from the actually Ethereum community, especially the kind of the mechanism design or governance or something like that. By the way, if I understand, the Ethereum is one of the internet native currency to executing the world computer. However, you mentioned about the two is kind of like an internet protocol to payment for the AI or something like that. So do you have any opinion to what is the difference with the Lightning Network for the AI stack, or payment by Ethereum currency to paying the decentralized execution? Because it looks like you mentioned about their services looks like centralized AI internet services are paid by our Lightning Network. So yeah, that's the my question.
Sorry, the acoustics are a little weird. If I understand your question correctly, it's kind of why could the Lightning Network stuff result in more decentralized like open source AI models, or?
Yes, some of the Ethereum projects trying to be a payment for the decentralized execution, for example, like AI.
Mm-hmm.
However, in your presentation, some example of the services looks like a centralized. However, it's accept to payment by a Lightning Network or something like that via internet protocol. So just wondering about your observation to kind of centralized services by Lightning payment or something like that.
Yeah, it's a great question. I think that when you think about, a lot of people are talking about kind of the nature of some of the open source stuff and some of the closed source stuff in AI. And I do think there's some services that I mentioned that allow for access to open source models. And in terms of our ethos and what we're excited about, everything for the most part that we do is open source, right? I think that by allowing people anywhere in the world to pay for these services, via Lightning and via Bitcoin, I think you'll have more decentralized, AI companies. The centralized companies are going to be more focused on, credit card payments, fiat payments, different things like that. I think you can get really creative with, what you're putting together if you're building AI products with this stuff, especially when you think about some of the macaroon stuff, because the identities there are, decentralized and the issuance and the verification are separated. You can give people access to a variety of different models and a variety of different tiers. And then, yeah, I think that answers the question, but if not, come up with me after, because, I'm happy to talk about it.
All right, thank you. We're going to wrap it up there. So another big round of applause for Michael.